When working with application and infrastructure, what I personally consider a good practice is separating the application components from the infrastructure when setting up source code repositories. This ensures that the underlying build and deployment process for each of these components do not cause tight coupling or result into unnecessary dependencies. What I mean by this is that I can quickly make changes to my infrastructure free of worrying about breaking the application and vice versa. However, there are certain use cases where it makes sense for both application and infrastructure to come together, especially if the framework and toolset allows you to do so. Like for example, in Terraform, I can actually build Docker images and publish those images into a repository like ECR. And today, this is what I'm going to do. Hello, I'm George and this is Pablo Spot, a space where I show and tell practical examples and sample implementations on DevOps and cloud technology in general. So without further ado, let's get into it. Let's start coding. The first thing that I need to do is update this repository and create my Terraform template files. So let me head to my VS Code terminal and run my script that will take care of generating the Terraform template files for this repository. And now, if I head back to my VS Code Explorer, the initial set of Terraform files have been generated. I'll start updating my Terraform code by heading to my backend.tf and update the parameters to ensure that I store my state files to my Terraform Cloud account. So I will set the organization property inside the backend remote block. And then set my workspaces block. I want to create my Terraform workspace now so I don't have to worry about this later. So let me head to my VS Code terminal and then export my TF workspace and then export my TF workspace prefix environment variable, which is essentially the same as the workspace prefix that I set on my backend.tf earlier. And then now I'm going to run my script to create my Terraform workspace with local execution. And now that these early requirements for my setup are out of the way, let me head back to my VS Code. And on my backend.tf, I need to specify the plugins or providers that I need to use in my code. So inside my Terraform block, I will add a required providers block. And inside this block, I will start adding the provider definition for AWS. This is the provider plugin reference that I will use when creating my AWS resources. The source property in this block tells Terraform that I will need all the necessary code syntax to be able to create AWS resources. And the version property is just an indication of which version of the source I want to use. The property AWS in this block defines how I will reference this inside my providers.tf. So if I head to my Explorer and open my providers.tf, the AWS provider block in here ties up with the AWS block that I defined inside the Terraform providers block in backend.tf. Now let me go back to my backend.tf. I also need to add another block for Docker. And this is the provider plugin that I will reference or use for creating Docker-related resources inside my code. And in order to use the Docker plugin, I will head to my providers.tf and define a provider block called Docker and set all the parameters that I need to be able to integrate with the Docker image registry or repository. This Docker provider block requires a registry auth block. And inside this registry auth are the address, username, and password properties. I am going to use ECR as my repository, so I need to set the address property to point to an appropriate ECR URL, which usually comes in this format. To derive the AWS account ID, I need to head to my data.tf. So let me open my VS Code Explorer and open data.tf. And define a data reference block to pull my current AWS caller identity, which is essentially the AWS account I used when I set up the infrastructure. Now back to my providers.tf. I can then update the AWS account ID component on this string and fetch the account ID from the caller identity data reference. For the AWS region in the string, I can simply use the region input variable that is added to my code by default. Now that my address property is set up, I need to set the username and password fields. For these fields, I need to use a data reference to an ECR authorization token that can be generated for me by AWS. And so if I head back to my data.tf, I will set a data reference to AWS ECR authorization token. and then back to my providers.tf, I will set the username property to a reference to the username property inside the ECR authorization token data reference. So it will look like this. And from the same data reference, I will extract the password property and use that for my provider password. And that's my providers all set. Before I start writing the necessary code to build and publish my Atlantis Docker image, let me first head to my VS Code terminal and run Terraform init. What this will do is load all the plugins into my session and allow my VS Code to recognize some of the code syntax necessary in creating the resources that I need. And now that Terraform init is done, let me head back to my VS Code Explorer and then open my main.tf. I am going to start writing the Terraform code that will build my Docker image and also publish it to AWS ECR. So the first resource that I need to create is the actual AWS ECR repository. This resource needs to have a name property which I will set to PS Custom Atlantis. The next resource that I need to create is the Docker registry image resource. This resource also needs a name property, which is the name of the Docker image and a tag. I can opt to set the name of this new resource explicitly to PS Custom Atlantis like what I did for my AWS ECR repository. However, I want an implicit relationship between my Docker registry image and my ECR repository. And so what I will do is use the repository URL property from my ECR repository resource for the name. For the image tag, I need to run a git command to pull out the short commit SHA. So this is how I'm going to achieve this. First, let me head to my VS Code Explorer. And inside my scripts directory, I'm going to create a shell script called get shortsha.sh. What this script will do is run a git command to pull out the short SHA commit and return a JSON data. And now that I have a script, I want this to be executed when I run my Terraform commands. And to do this, I will head to my data.tf. And then in here, I'm going to define a data reference called external. This will need a program property which I will set to a shell execution of my new shell script get short SHA script. And now, if I head back to my main.tf, I can then update the tag component in the name property of my Docker registry image by pulling out the SHA value that is a field inside the result property of the external data reference. So it should look like this. My Docker image resource also needs a build block which contains a context property. This context needs to point to the root of the repository, so I will assign path.cwd or current working directory to the context. And that's all the code changes that I need. Now let me head to my VS Code terminal. And the first thing I will do is change the permission of all my shell scripts to executable. I already exported my Terraform workspace on this session, but I need AWS credentials initialized, so let me run AWS Vault. And then I am going to rerun Terraform init. And then run Terraform plan. And then run Terraform apply. The Terraform apply was successful, and to verify that the Docker build and publish are working, let me switch to my browser. and head to my AWS Web Console. And from here, access ECR. So the repository has been created, and let's go ahead and open that. And it contains one Docker image with the tag that coincides with the short SHA commit. And that's all I have for today. On the next episode, I will flesh out all the environment variables that's required for my Atlantis service and store them in parameter store in AWS Systems Manager. In the meantime, let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.